Okay, Trinity, I apologize because we are, Trinity, we are in the bottom of this, and I kind of started, and then somebody said, Devin's covering your back over here. She goes, are you recording? Crap, I forgot to record. So, we started this already. We did domain, and we did vertical asymptote, so there's that. We're getting ready to do the y-intercept. We said you have to plug 0 in for x, but we just said x can't be 0. So, what happens to the y-intercept? What happens to the y-intercept? There is none. There is no y-intercept. None. The x-intercept. How do I find the x-intercept?
Plug in 0 for y.
0 for y. 0 for y. Well, there is no y, but y is really g of x, so 0 equals 2x minus 1 over x.
Y is no y.
All right, now what?
So, multiply the x.
Multiply the x, which makes, like, the whole bottom go away. You will find that every single time you find x-intercepts, you're really only finding the top, right? The top is the only thing. So, 0 equals 2x minus 1. Can you do that in your head? 2x minus 1. Add the 1, divide by 2.
Half.
1 half. Add the 1, divide by 2. X is 1 half. That's where he's going to cross. All right, then we have Ha's. A horizontal asymptote. Ha's have to do with n and m. Have we talked about n and m yet?
Yeah.
Yes, okay. My trig class is doing this exact thing right now, and they didn't talk about n and m yesterday. So, n and m. What is n for this thing? 1. What is m? 1. So what's the rule?
LC over LC.
LC over LC. 2 is the leading coefficient to the top. 1 is the leading coefficient to the bottom. So y equals 2 is my ha. Okay, so I went ahead and provided the answer to this for you down below here so that you can see my ha is at 2. My va is at 0. That's this guy. He's touching at 1 half right here. And he's doing the 2 little boomerangy things. Okay? That's just verifying all of that other information. Good, good? Makes sense? Next page. All right, one more thing we have to talk about, which is a slant asymptote. So we've done Ha's, we've done Va's, now we have to do slant. Okay, a slant asymptote is going to be like sideways. A sideways line. All right, and a slant asymptote only occurs. You will only have slant asymptote when n is 1 larger. This is probably really hard for people watching this video. Sorry, Trinity, because it's delayed. 1 larger than m. When n is 1 larger than m, you will not have a slant. You will have a slant asymptote. Okay, the rule for ha said that if n was bigger than m, you don't have a ha, right? But a lot of the time you will have a slant asymptote instead of a ha. Now, it's always the case that if you have a ha, you don't have a slant asymptote. If you have a slant asymptote, you won't have a ha. But do you have to have one or the other, or could you have neither?
You can have neither.
You can have neither. Like, let's say I have x to the 3rd power over x plus 1. N there is 3. M there is 1. So he has no ha because n is bigger than m. But is that 1 larger?
No.
No, so he does not have a slant asymptote. Does that make sense? Yes, so he might not have either. The slant asymptote is found by using division. Now, it says long division, but if this is the problem, x squared minus x over x plus 1, could you technically use synthetic? Yeah, you could technically use synthetic. So, whatever type of division you use, this guy right here is what I get as an answer. And the slant asymptote is everything except the remainder. The remainder we do not care about. Your slant asymptote is y equals x minus 2. Okay? The equation y equals x minus 2 is linear. And to graph him, I go down 2, and I go up 1 over 1, up 1 over 1. And this is what my slant asymptote will look like. Right? It's a linear function. That's what my slant will look like. Okay? All right, so while we're on that, let's go ahead and do that same thing for this one.
Oh,
Okay. Let's do the slant asymptote for that one. They're going to ask for everything, but let's do the slant asymptote for that one while we're on it. Do you want to do long or synthetic? Synthetic, sure. You hate synthetic. What goes on the outside? 1. And the numbers are 1, -1, -1, -2. 1, -1, -2. Okay? The 1 goes down. 1 times 1 is 1. Shh. This becomes 0.
Yeah.
This becomes 0. 0 is here. -2 is the remainder.
Oh.
So this guy will look like x plus 0 minus 2 over x minus 1, right? That's what he will look like. But
There's no 0.
we don't care about the remainder.
Oh, true.
So what's the equation of our slant asymptote? Y equals x plus 0, or just y equals x. Now y equals x starts at 0 and he goes up 1 over 1 like this line says. Right? Okay, y equals x is that slant asymptote. Does that make sense? So let's go over here and let's mark that. Y equals x. There he is. Okay, now let's do all the other stuff. Y-intercept, x-intercept, vertical asymptote, additional points, etc.
Oh.
Will he have a ha?
Yeah.
I can't ever keep track. It's
Why does he not have a ha? Because he has a slant. If he has a slant, he won't have a ha. That's the way it goes. All right, the y-intercept, plug 0 in for x. 0 in for x.
It said it does. It's not even up there.
All right, so if I put 0 in for x, 0 squared minus 0 minus 2 all over 0 minus 1. What does that make? Your y-intercept.
0 minus 0 minus 2.
-2 over -1, which is 2. That's my y-intercept right here. That dot is 2. The x-intercept, shh, be quiet. The x-intercept, you plug 0 in for y. So I have 0 equals x squared minus x minus 2 over x minus 1, but same thing happens. The bottom goes away, right? Because you're going to multiply the bottom over and he's going to cancel out because anything times 0 is gone. So if I'm trying to solve x squared minus x minus 2, can that be factored? Yes, how? X minus 2, x plus 1, right? -2 times 1 is -2, -2 plus 1 is -1. And then x equals 2, and x equals -1. So 2 is here, -1 is here. There they are. All right, now, assuming I don't have this graph, that's all the information that I know on here right now. That's all the information that I know. So what would be a good idea is to maybe plot some additional points on here. So like, you don't necessarily have to do the test interval or representative value of x. I do know that if I plug 0 in, no, if I plug 1 in, it's undefined. If I plug 1 in, it's undefined. So it wouldn't be a bad idea to plug 2 in, and 3 in, and 4 in, and 0 in, and -1 in, and -2 in, right?
Why?
Just so that we have some other additional points and we know what he looks like. Okay? So, what are some other points that I already know on here? I know that zeros occur at where? 2 and -1. So this is 0 and this is 0. 0 and -1. But if I plug the rest of them in, like if I plug 0 in for x, oh, we already know that one also. That's 2. We know those points. If I plug in like -2 and 3 and 4, it will give me some additional points on here. Like 3 will be at, I don't know where that's at, like at 2 maybe. 4 will be up here at like maybe 3.5, something like that. -2 will be down here at like -1.5 maybe. I don't know. Okay? But you plug those into the equation and it will give you more of a general idea of what he looks like, and then you can just connect the dots. Does that make sense? He looks like this and he looks like this. Like he kind of looks like the Hurley H. guys know what I'm talking about? The whirly H, that's what he looks like. Because he has a slant and he has a vertical. He's kind of bounded by those two little things, yeah? What?
She said she gave me her one.
I'm going to do
There you go, that's all.
it.
That's all.
Time to
Done. Donezo.
One more question.